Well, hi, good morning, and welcome to my shop. Thank you for joining me and my granddaughter in here for a little bit of fun. What are we going to do, Zita?
We are going to look at the meter.
At the meter? What meter?
The meter right here.
That's right. Very good. Holding it up to the camera. Very good. Have you ever used a meter like that before?
No.
Any idea what it does?
No.
No idea what it does. Any idea what we're going to do with it?
Test the batteries?
Yeah, that's right. We're going to test the batteries. Okay, so look at this thing. This is an old one, by the way. I'm not even sure this one's going to work. But we're going to give it a try. Okay, look here. Don't look up there. Look here. Okay, see a bunch of numbers on there?
Yes. It looks like there's a 0, a 200, a 400, a 600, an 800, and a 1000.
That's this black scale you just read, isn't it? This one here, right?
Yeah.
Yeah. There's another one just below it. See the numbers on that one?
Yeah. 0, 5, 10, 15.
Very good. And then look at this weird one on the top. Where's the 0?
0. No, 0.
Yeah, it's on the other end.
1, 2, 3, 4, 5, 6, 10, 20, 50.
That's right, yeah, it gets real crowded up at this end. So there's different scales on here. So when the pointer goes up, you read the different scales to get numbers. You see these different holes here?
Yes.
Look, you can pull this out, and we can stick it here. You stick these in certain spots, then you read a certain scale up here that matches. Let's see if we can figure that out. So you won't be able to understand everything, but this is a good place for this black one right here. And the red one is in the 150 hole. What do you think that means, 150? Any idea what scale you'd look at here?
No.
No, that's kind of tough, isn't it? Here's one down below, it says 15. So you plug it in here, we're on the 15 scale. Can you find a 15 scale? That'd be the top number is 15. The biggest number in the scale would be 15.
But why is that not the biggest one?
Well, this is 1,000. So if you want to measure 1,000 volts, which I'll tell you about in a minute, or 150 volts, or 15 volts, you set the scale here. It went 0, 5, 10, ends with 15. So 15. So if we put the wires here, that means you read this scale here. This one that goes up to 15. Okay, what?
But why is it not at the 15?
Well, there's no power going into it. We need to get a battery. Here's a battery. Here you go. Hook it up. No, you hook it up. You got two hands. You can hook it up. I'll hold the battery and you hook it up. Anything happening?
No.
How come?
Because you didn't put the actual battery in.
No. I'll give you a hint. Okay. See this end?
Yeah.
And see that end?
Yeah.
That's the hint.
So you have to do that?
Watch the meter now. See it move?
Yeah. When I move this, it moves.
Which way did it move?
This way then that way.
If you hold them on steady, which way did it go? Can you tell? Okay, take them off. It went backwards, didn't it?
Yeah.
Well, if the meter goes backwards, the leads are backwards. Flip them around and try again. That's it. Try again. Now it goes up. What do you think's happening?
It needs battery to work. So, and this one has to be on the right end, and this one has to be on the right end. And it's plugged in, so some of the battery goes down in both. then it goes in here, then that works.
That's about it. You got it quite right. When you said some of the battery goes, you should have said some of the electricity goes. That's what's happening. You're sending electricity down these wires into the meter, and then for some reason the meter goes up. Okay, what do you think? Think this is a good battery?
Yes.
How do you know?
Since it's working.
Since it's going up?
Actually, no, I don't think it's good.
How do you know?
Because that's a small one and that's a big one.
Well, you're right. This one has more voltage. This will make the meter go up higher. Should we try it?
Yeah.
Okay, try it. Now, we don't know if these are good or not, so try it out. Oh, went backwards. You know what that means? If it goes backwards, what do you got to do? Exactly. Exactly. Go ahead. No, what are you doing there? You're doing some kind of magic trick? Try it again. Because I think you just got it backwards again. Yeah, meter's going backwards, so lead's got to be switched. Very good. Oh, just touch very carefully, yeah. Goes a lot higher, eh?
It goes to like 600.
600, so you're reading the wrong scale. Remember, we're on the 15 scale, so if you read the 0, 5, 10, 15, what number would that be on there?
At 10.
It's a little less than 10. What's a little less than 10?
9 or 8.
9 or 8. Let's look at this battery. What's it say there?
9V.
9V. The V, it talks about the pressure or the power of the battery. So look, it's supposed to be a 9, and you read a 9. It's a good battery. That one. Any good? Did it go anywhere?
No.
Did you see it go anywhere?
No.
Not at all. Let's try it the other way. I'll turn the battery around. You can keep the leads the same. What do you think? What do you think of that battery?
Maybe it's out of electricity.
It's out of electricity.
Inside.
That's right. That's right. This is an old one. But also, see, it says 9V. The V comes from a guy's name, Volta. Some Italian guy. Do you know where Italy is?
No.
Italy's a country way over in Europe. A guy named Volta was a experimenter, doing stuff like what we're doing. Kind of. And to remember him, they use the V and the word volt. A lot of stuff is like that, you know. The names of stuff is coming from people that are trying to be remembered. Okay, so this is a bad one. I'm going to put it over here.
You want them sticky?
Which of these are good and which of these are bad? I'll turn them all the same way.
Can I test them?
Go ahead, test them. Test them. Give those guys a test.
Bad.
No. Was it bad? Or did it go the wrong way?
Oh yeah, it went the wrong way.
Yeah. Okay, try again. Good. Right up to the number.
Good.
What number did it go up to?
10. No, 9.
Right. That's another good one.
7.
Well, I think it was closer to 8, that one. They're all good. These are all good 9-volt batteries. Very good. Okay, here's 2 more to test.
Bad. It's a bad one. Or maybe I have to do that. Bad one. Bad.
Bad ones? Okay. Now how high do you expect the meter to go?
Close to 10 or 15.
Close to 10, eh? Because, well, let's look on here. Because you think the number 9 shows up on this battery?
No.
What number shows up on this battery? Wow, it's really hard to read. We need one with a...
Double A.
Can you see something with the V? The V number? In there? Anywhere? It's a
No.
double A, that's right.
Yeah.
Good till March 2035. That's quite a while from now. Okay, so I can't read this, but I'm going to use a magnifier. And nowhere on here does it give what its V number is.
That's why it's a bad one.
That's kind of strange. We need batteries that have a V number on them. A volt number. Well,
That's why they're bad, since they don't have the V.
Okay, here's one. Here's another battery. Look at this one now.
Whoa.
With lots of stuff written on it. Can you find what the voltage is of this battery? I'll give you a hint. I'll turn it like this. It's written here somewhere. It's written in the gold area. Can you see it?
Yes.
What do you see?
1.5 volts.
Exactly right. Okay, test that battery. Oh, wait a minute. One more thing. If it's going to be 1.5 volts, how far up is this meter going to go? It's not going to go all the way to 9. How high is it going to go?
To 5?
Why would it go to 5? It's 1.5.
Or maybe it would go to 1.
1 and a 0.5 is a little more, right? So a little more than 1. Now where's that? That's way down here. It's hardly moving the meter up. So a good battery doesn't necessarily go all the way to the top. It matches what the number is, the V number or volt number on the battery. So 1.5 volts, it should come up to the 1.5 area. It's just a little bit up. Give her a try. We don't know what condition it's in. It could be good or bad. Okay. Careful now when you do it. That's right, you gotta make good contact. Oh, it went up. That's roughly 1.5, 1.5. The battery is it good or bad?
Good.
Good one. Right on. Okay. This is a simple meter.
Oh no.
What happened?
That fell. That.
I have another. This is an old meter, by the way. This is pretty old, and this is the kind of thing people use to test batteries and not much else. We're going to switch now to a more advanced meter. Still really old. You can take it out of there.
It's in here. It's a different kind. It has a switch.
Let's see if we can get it out. Maybe it's held in here. Normally you wouldn't take it out, but I did. Normally you would just keep it in the case. There's the leads. Better take the leads out. Okay.
Oh, I think I know where they go.
Now, right away. Do you see differences and do you see anything similar?
Differences.
What's the difference?
This one's bigger, plus it has the switch in there.
That's right. The other one, the switch didn't have a switch.
So does this one go in here?
Yeah, wait a sec. The other one doesn't have a switch. Instead, you're putting these in different holes. That's kind of the switch. This one, you already figured out where those go. Okay.
Where are you, Weddy? Weddy, Weddy. Weddy, go in here. But how come there are 3? One there.
This one is a special one for really high voltages, really high volts, like really high, 5,000 volts, and we're fooling around with 1, 2, and 5. Okay, little hint here. You see how one is red and one is black?
Yeah.
And you saw how when you reverse the leads, the meter goes this way or that way?
Yeah.
So this is really important, getting it right. That's called polarity. Because the batteries have poles. This is a pole, and that's a pole. And if it's important which one you hook up to, then you say you have to be careful about the polarity. So I'm putting this black one here, because I know that's where it's supposed to go. You don't know that, but I do. And this red one should go here. V, ohms, and amps. Yeah, it should. Yeah, I'm telling you it should. Okay, now we got to figure out this setting here. This is a little tough for you, so I'm just going to do it. You ready?
Yes.
Look at the meter. Do you see? Yeah, you're looking at it? 2.5 volts, 10 volts, 50, 250, 500 volts. So
That's a lot.
what would you guess we should set this to get a good reading from a little battery?
2.5?
Exactly right. You're exactly right. Because now, 2.5 volts, I make the pointer go all the way over. If you had it up here at 50, it'd take 50 volts to get the pointer to go all the way over. Batteries only have a volt or two, so they would hardly move it on the 50. But 2.5, where do you think? Let's use this one because we know this one's good. Where do you think that one would show on the meter? Before you test it, where do you think it would show? Well, you gotta look at all these scales. Find the one that ends with 2.5. There's one there that ends with 250. That's good enough. But you have to pretend now. You gotta use your brain here. This is not something.
2.5.
This is not something 6-year-olds normally do. Okay, so you're traveling in adult land here when you're looking at this. That's right. So you pretend the 250 is 2.5, and then you look for 1.5. It would be here. So if that meter's good, if that battery's good, this meter should come all the way up to here. Go for it. What do you got? Only don't block the meter, the view of the meter there. Okay, what's the meter doing?
Nothing.
Yes, it is.
Huh? Going.
Try again. Watch the meter. You gotta watch it to see when it moves. Take off. Do you see what it's doing?
Yeah.
What's it doing?
So, I don't know why, but when I hold it on, it's going backwards. But when I let go, it's going forwards.
Well, it's not going forwards when you let go. It's just going back to its rest point.
So it goes backwards, then back to its rest point.
What do you do to make it go forwards then? That's right. Okay, try it now and see if it goes up where I said it would. Look at that. That other meter just gave you a little movement. This one, go all the way up to here. You can see quite clearly that's a good battery. Here, try another one. Ah, you knew enough. I gave it to you backwards, but you're too smart for that. That's another good one.
It's past though.
Okay, and we'll try the next one. And then I'm going to ask you. Not as good as the others, is it? About half.
That's because it's running out of battery?
It's running out of energy. Electrical energy. Batteries, they only have so much energy in them, and you use it.
Let's test this one.
Okay, but wait. That's a 9 one, right? And the top of this is only 2.5. You haven't got room for 9. So you need to change this setting. What would you change it to? What's that one?
10.
Yeah. Go ahead. Change the setting to 10. Okay. So now you know if it's a 10 volt battery, it will go all the way to the top. But it's only a 9 volt battery. Good. Give it a try. I apologize to the viewing audience. I'm not keeping the focus or anything while I do this. What do you get?
I got almost 240.
Wow, you can really read this, but you're reading the wrong scale. Okay, so you're on the...
Come on.
Look, stop for a sec. You're on the 10 scale. So one of these scales goes to 10. Can you see which one it is? No, the very end is 10. The very high end is 10. You see it right there? Just below my thumb. It says 10 in black.
There?
No, not that one. Down lower. Just above the red scale here is the number 10. Right below my finger. That one. Yeah, see that 10?
Yeah.
That's the scale. So 10, 8, 6, 4, 2. Okay, take a reading. Okay. Go. Did you see what it was?
It was just after 8.
Just after 8. Just a little more than 8. But it's supposed to be a 9 volt battery, isn't it? So what that tell you about that battery? It's a little worn out. It's going down. It's had its day. Very good. If I were to read that, I would say that was 8.4. Because you see there's the 8 there and a 10, and in between is the 9, but they didn't write the number 9 there because there's too many numbers to write, so they just left it. You got to think that. You got to realize that. So yeah, so it's not dead, but not great. Now I got to ask you this question. What's making this pointer go up? Okay, I'm going to give you a hint. It has something to do with things like this. What are those things? One of them just disappeared. What are those?
I don't know.
Sure you do.
Magnets.
Magnets, right. And they
Come
push.
on, stick together.
And they do funny things, don't they?
Come on, stick together, you magnets.
Yeah.
No, thing. Come on, stick together.
Yeah.
Is this a south and a
So
south or a north and a
look
north?
what's happening. The magnet is pushing on your hands, isn't it?
Yes.
The magnet is pushing on the pointer. There's a magnet in here. But it's more complicated than that because you have to have electricity involved. And I won't explain it in detail, but there's electricity going through, turns something into a magnet, and it pushes on the other magnet that's already in there, and it makes the pointer go up. Very good.
I got this now.
Okay, what do you want to do next? What do you want to try next? Now you know a lot about meters. You know a lot about meters. What do you know about meters now?
They have magnets inside,
Like
which I
that?
did not know before.
Yeah. Look, you take this magnet. What happens if you hold this magnet near the pointer? See it move a little bit? Not much. Not as much as I was hoping. It moves a little bit.
I just see it a little bit though. Come on, stick. Wait, so I think I know why they don't stick.
Why?
'Cause it's either a north or a south.
Well, you know about magnets. I'll tell you something though. The thing you're feeling right now, with the magnet is pushing against each other, that feeling, nobody knows exactly what's going on there. You know? Not exactly. Not in the deepest detail of what is going on there. And for my viewing audience, magnetism is actually an expression of an electric field when quantum mechanics is taken into account. Let that roll around in your head for a minute. What I just said is there's no such thing as magnetism. It's all electric fields. It's just quantum mechanics gives us this experience. Strange as it is. Just like gravity is a really strange thing.
How does gravity actually work?
Oh, you know what? That's another thing that we all experience every day in every way, and nobody knows exactly what's going on there.
But
Well, I shouldn't say that. There are ways of understanding it, but it paints a pretty weird picture of what's going on in the world.
but
Okay, do you think
why,
we're done?
No, but why is there no gravity in space, but there's gravity on Earth?
Well, that's an interesting question. There is gravity in space.
Huh? But then
The
why?
real question you have is how come the satellites aren't falling to the ground? Is that right?
Yeah.
Because you think there's no gravity, so they stay up there.
Yeah.
And if you see people inside the spacecraft, they seem to be floating around like there's
Yeah.
no gravity. But the fact is, they're actually falling towards the Earth. This is hard to understand. Let's say, I better not use this. I need something round. Okay, this will do. Let's say this is the Earth. Okay, this square thing is the Earth. And you've got the satellites going around with the people in them, maybe the space station and the people around them, and they're floating.
From NASA?
They're floating, but there's no way, there's no gravity. What's happening is they're going fast this way. Here, watch. They're going fast this way and being pulled down at the same time. So end up curving. They end up curving around the Earth. And what's happening to the people inside the spaceship while it's doing this is they can't feel the gravity anymore. Gravity's there. Gravity's everywhere. Nobody really knows what it is. Pretty strange, eh? Don't you think?
Yeah.
That there's this stuff that we see all the time, and it's really quite mysterious stuff, like electricity. Like, what's happening? What's going on in these wires? How come this thing's going up? Lots of mysteries about stuff. And the great thing is, people figure out these mysteries, and when they figure them out, they realize they can do stuff. When they figured out magnets, they made meters. When they figured out magnets, they made motors. All dependent on magnets. There's even magnets in your telephone. And yet, nobody knows exactly in detail what is going on. What it is. I should be clear. Nobody knows what it is. People know what they do, but they don't know what it is. So they know, you hold magnets together, they push back and forth.
But not with all
But
magnets.
exactly what's going on there. Somebody's got to figure that out someday.
But what if no one figures it out?
Well, no one's figured it out exactly to this point yet. Look at all the stuff we have. We have meters, we have motors, we have all kinds of stuff. You don't need to know everything. But it's helpful, that's for sure. Okay, are we done?
Yes.
Do you feel better about meters?
Yes.
Do you think you can test a battery from now on?
Yes.
Okay, I got one more for you. Look at this one. Okay, this is also a meter, but it doesn't have a pointer. It's going to read numbers. Now watch. I'm going to take this battery, I'm going to put it in here, I'm going to close this. Do you get a number?
Yes.
What is it?
It keeps going down, I don't.
Well, the battery's going down just from this thing.
3.1.
No.
No. 0.3.
0.3. It's supposed to be 1.5. This one seems really dead. Let's compare it on this
Dead
meter.
battery.
We're going to compare it on this meter. Look, I'm going to flip this to 2.5, okay? Because that's a better one. I'm going to put the black one here. Oops. What was that number again? That it read? Okay, and on there. Now we're on the 2.5 scale. I read that as just over. I'm having trouble myself here. Just over half a volt. Just over 0.5. Just over 0.5. Now let's see this one. Does this tell the truth? Just over 0.5. Because I can't remember. Okay, here we go. Here's the reading. It's a little under.
0.3.
Yeah, it's a little under. This meter seems to give it a little extra reading. There we go. So now you got a digital meter, indicating meter, and you can see there's meters all over my shop. Look at them all. Look, I got this one, I got this one, I got this one, I got this one, I got that one, that one. If you look over there, there's more meters over here, all kinds of them. All
over there.
over the place, yeah.
Right over there.
Yeah. They all have scales.
There.
Yeah, they have scales.
There.
That's not a meter.
Huh? What is it?
That's not a meter.
What is it?
Well, that's just that's something for making signals. There's a meter here too. Look at this one over here. All these meters are there to help know what the electricity is about.
Figured I'd get changed and we could go out and do the hike thing.
Oh, okay.
She's pretty eager to go.
Okay.
Maybe we can
Finish the
do a
show.
truncated version or something.
Finish
We're gonna
the
finish
show.
the show here because we're on the air, and we'll be out in a second. Okay, so we're gonna do a hike next. We're gonna do a hike. You know where we're gonna go?
No.
We're gonna hike back 450 million years. We're hiking back to a
No.
place. We're going to stand in a place where our feet will be touching ground from 450 million years ago. And you know what else we're going to see when we look at our feet? The animals that were alive then are down there to be seen. That's where we're going to go.
Like dinosaurs?
No, this is long before the dinosaurs. This is so
Thank
long
you.
ago, Zeta. There was nothing living on the ground. It was all in the ocean. And we're going to be standing on old ocean floor. That's what we're going to do. Okay, without turning around, say goodbye to the nice people who watched us this morning.
Bye.
Okay, and I'll say goodbye too. Bye-bye.
Bye-bye.